the purpose of this video is to introduce you to R. And in doing so, the first thing I'd want you to do is open up a browser. And I'm actually sharing my desktop with you here. I changed my desktop picture to appropriately show R. I'm going to open up Google Chrome. Again, use whatever. And what I would do is just go to google.com. And again, I'm not like on Google staff or anything, so I'm not getting any kickback for recommending this search engine. But guys, at the end of the day, just type R and do a search. And the very first thing you're going to see, more than likely, is the R project for statistical computing. So I want you to click on that. And of course, this is where we begin the process of downloading R to our computer. Now, it might be a little easy at first to get overwhelmed by everything, but at least for now, we don't need to worry about much more than just downloading it. So I would come to this part right here which says to download R and click it. And the first thing it's going to ask you to choose is a comprehensive R archive network. Now, this is important, so we'll have access to the same data sets, we'll have access to the same code. The one that I use, and I've tried quite a few of these, and I really don't know why I prefer this one, but I just do. And it's going to be the one I'm going to use, so you'll definitely want to use it too. Is this one right here, the University of California at Los Angeles. So I'm going to click this. The next thing you're going to do is you're going to download it according to the machine you have. If you have PC, you're going to choose Windows. I have Mac, so I would choose Mac. So again, choose whichever is the download that corresponds to the computer you use. And the next thing is I would search for this, where it says latest version. There's no need downloading something that may have some bugs that haven't been fixed yet. So download the latest version. So I'm going to go ahead and click this as if I really wanted to download it. And you can see down in the bottom it says, says either keep or discard. It's probably going to tell you that this file can harm your computer. I don't know what to tell you. Proceed as you think best. If it's your parents' computer, ask them. I've seen nothing that, no news, no reports, no information at all that indicates this is not a safe download. Now, guys, once you download this, you'll be asked to go through the installation process. I found it to be extremely simple to do. And again, I've already got it downloaded, so I'm not going to go through that. But nevertheless, once you complete the installation process, either on your desktop or possibly in a download file, wherever you put it, you're going to have an icon that looks like this. So I'm going to click this. And what I did is I just opened R. And I'm not going to get into this a lot now because I want to break R down into... okay, guys, this is going to be the final video that we have in terms of descriptive statistics. And I think it's probably one of the more exciting ones because what we're going to do is put everything that we've learned together and learn to analyze data using R. Now, I need to do a couple of things first, okay? First of all, I've got this data set on my desktop, and you can see that this data set is in XLS format, and it's got a lot of data, a lot of numbers here. I think there's right around 900, maybe 1,000, but quite a few measurements. And the first variable that we have is high school GPA. The next variable we have is first year college GPA. The next is gender. And the next two scores, verbal and math, those are verbal and math SAT scores. And then this is the high school region. So for example, the 18th participant in this study was a female. They had a 3.2 high school GPA, a 2.15 first year college GPA, a full 40 verbal SAT, a 530 math SAT, and their high school was located in the Northeast region. Now, to get this data set prepared to go into R, here's what we have to do. Although it can be done, the most seamless, okay, let me back up. It can be accomplished that you can take an Excel data set and move it into R where we can analyze data. But I found the most seamless way to do this is to convert it to what's called a CSV format, convert it to a text file. So what I'm going to do here is I'm going to come to Save As. And what I'm doing here is I'm converting what I currently have as XLS format to CSV. Now, the first thing I want to do is I want my data set to have a simple name. And I usually do these all cap. And in this case, since SAT is a variable broken across verbal and math, I'm going to call this SAT. Again, I want something simple, all caps, only one word. Okay. Next thing, decide where I'm going to put this. Guys, I always want you to save this file on your desktop. Reason being, I'm going to show you how to manipulate some things here in just a second to where it will go to, R will go to your desktop and search for the file. And really important, you need to come down and transfer your file to comma separated values format. Now, guys, again, let's go over this because this is, you know, even the smallest mistake can create major headaches later on. First thing, save it as something simple. One word, all caps, 3 or 4 letters tops. Save it to your desktop. Now the default is probably going to be documents or downloads or something like that. I don't want it there. I want to show you how to take files from your desktop and convert them into R. The next thing, we need to have text file. And guys, it needs to be CSV. If you're working with a Mac, it's going to be here. If you're working with a PC, it's going to be down in here someplace. But look for .csv. Now, once you get that, I'm going to hit save, and it's going to go through all kinds of wacky stuff. It's going to say, you know, cannot be saved in selected format. Ignore that. Save active sheet. It's going to tell you other stuff. Ignore that. Continue. Guys, what I've now done is I've saved this data set on my desktop as a CSV format. Now, I'm not going to need this anymore because I am going to not save because I have the file that I need on my desktop right there that I've named SAT, and it's going to be a .csv. All right, let's go open up R. And also, I've got another document here that's going to be the assignment. So the assignment we have here is use the data set high school GPA, SAT gender. Remember, I renamed that to SAT. So scratch through that. I've renamed this SAT, and it is a .csv file to answer the following questions. Guys, again, it is critical that you convert these files to CSV. Sometimes I can upload files in XLS format, but this is the most seamless. It will provide the least number of headaches in you converting an Excel file into R. Okay, so we need to open this in R, and then what I want to do is first of all teach you actually, I'll tell you what, this is a math class. Let's just go with math. I want to teach you in R how to find the mean, the median, the standard deviation. I want to teach you how to do construct a box plot, and I want you to learn how to construct a histogram and identify the distribution shape. Okay? Now I've got another question here which will be in the next video. This first video is going to take a little longer because there's a little more to converting the file from your desktop and getting it into R. Okay? All right, gang, here we go. Let's get into R. The first thing we've got to do is we have to get our working directory. And you do that by just going getwd. So this gets our working directory, and my working directory, which was set as the default when I installed R on my machine, is users ddarbro. Well, I don't want that. I want to set my working directory to my desktop. The working directory is where R is going to go look for your data set. And I'm always going to upload things, save it to my desktop. So I want to set my working directory to desktop. Now then, you know, this problem when you log out of R, a couple of days later you log back into R, you have to do this again. Now, if we did everything correctly, we're going to hit enter and nothing's going to happen. I always like to just be safe and have R get my working directory and make sure that I've set it appropriately. Now by default, when I tell R to go get a data set, it's not going to look anywhere. It's not going to look downloads. It's not going to look in my file, my documents. It's going to go to the desktop and look at it, and then look for the file. Now, next thing I need to do is I want to name this something, and I'm just going to name this my data. And the command I use is called read.csv. And if you remember, I called my data capital S, capital A, capital T, CSV. Guys, this has to be in quotations. The CSV has to be lowercase. And whatever the name of the variable is has to be exactly the way you named it on your desktop. Okay, again, no error, nothing popped up. It's going to be kind of weird at first. That's a good thing. If we see red stuff pop up in terms of errors, then that's a bad thing. Now, what I can do now is just type my data, and you'll see that I have the data set that was in Excel format into R. Now, guys, remember, these are cases. First case, second case, third case, fourth case, all the way down to 1,000 cases. We sometimes call those individuals. The things that we have at the top are called variables. This data set has 6 variables: high school GPA, first year college GPA, gender, verbal, math, and high school region. High school GPA and first year college GPA are quantitative. Verbal and math are quantitative. Gender and high school region are categorical variables. Now, we've got our data there. We can see it. And you would think that we are ready to do some, find some things. Find means, find standard deviations, construct box plots, and so on and so forth. So let's try that. And I'll tell you right now, it's not going to work. If we go to mean and we type in math, we get an error. And it says that the object math is not found. And the first time this happened to me, I scrolled back up and wanted to make sure I didn't misspell it, or maybe everything wasn't capitalized, or, because it's got to be typed in perfectly. Now look back up and it's there. It's a variable in the data set that I successfully downloaded into, or successfully transferred into R. So why is it not seeing math, the variable, when I know it's there? Well, it took me a while, but I realized that what you have to do before you start working with a data set is you have to attach it. So I named the data set my data. again, back up here. When I initially read the data from the desktop using this function read.csv, I named it my data. So I want the entire data set to be attached so I can analyze variables in the data set. So guys, what I have to do is I have to attach my data. Again, I'm going to hit enter and nothing's going to happen, which is good. Now I can go to mean math and I get the average. I can go standard deviation math and I get the standard deviation. Guys, you have to attach the name of the data set before you can actually work with it. All right, now I want to create a side-by-side phenomena here with the document that I'm going to be working on. So I want both of these going. So what I want to do is for math, I want to, I'm going to put these in red. What I want to do is I want to find a numerical summary for math, which I did. But there's actually an easier way. Let me show you. You actually get more bang for your buck if you'll do this. There is a command summary for a variable that gives me a lot of what I want. Now, this gives me the minimum value, first quartile, gives me the median, the mean, the third quartile, and the max. This is going to fit nicely to find the IQR. It's going to fit nicely for us to find the range. The only thing really we need to create extra would be the standard deviation and the variance. And I'll show you how to do that in just a second. Well, we've already done standard deviation. So guys, the mean over here is going to be 543.95. The median now is 550. The standard deviation is 84.50. All right, the range. R actually has a command range, but it won't give you the range. It'll just give you the highest and the lowest number. Well, if you think about it, we already had that right back here, but nevertheless, we can go 770 minus 290, and we see that the range is equal to 480. So I want to go back over here and type in 480. Guys, descriptive statistics are given to the nearest to two places. Q1 we can see is 490. Q3 is 600. And the IQR, which we could get by taking 600 minus 490, but sometimes that mental arithmetic gets us in trouble. Had that right the first time. And that's kind of cool that that happened, actually. Sometimes mistakes are good. So notice that this IQR and that IQR, to a person, those essentially the same thing. To a machine, they're not. And remember, we're communicating with the machine here. So IQR prompt has to be all capitalized. So I'm going to go over here and record the answer of 110. And the only thing else I have to get is the variance. Remember, the variance is nothing more than the standard deviation squared. So we could go, let me go over here. We could take the standard deviation of math and square it, or we just could go variance MATH. So either way, we get the same answer. So we'd want to go to our worksheet here and write down 7140.44. Okay? Seem like something you can do? Absolutely. So R makes it very, very, very easy to find descriptive statistics for variables. Now, something kind of cool is R sees the difference between gender and math. it sees the difference between a categorical variable and a quantitative variable. So if we do summary for math, back here you see that we get the 5-number summary plus the mean. But if we do summary for gender, well, it realizes that we can't calculate standard deviation, means, and medians, that it's actually going to give us the count of the number of females and number of males that are included in the study, in the data set. All right, next thing, if you go back over here, part B, the next thing we want to do is we want to be able to create a box plot. The command for box plot is box plot. Simple enough, right? Now when we do that, an extra window is going to pop up. Now sometimes, I've seen this happen, and it drives students absolutely crazy. Sometimes it'll happen where this will hide. If that hides on you, what you have to do is you have to come up here and minimize this to actually see your box plot. Okay? So our box plot, first question over here is, are there outliers? Well, yes. And there are, what, 1, 2, 3 outliers below, and there's 1 outlier above. So there are 4 outliers. Now again, keep in mind that the 3 outliers at the bottom are the 3 lowest values, and the outlier at the top is the highest value. So next question, how many and what are their values? What are the values? Well, we have to, let's close this down and bring R back up. And we have a command in R called sort. What sort will do is it'll take the 1,000 numbers and sort them from lowest to highest. Well, our 3 lowest values, which would be 290, 310, and 320, were outliers. So the values would be 290, 310, 320, and the other outlier was the biggest value. So we have to go all the way to the end of the data set, and we see that 770 is the value there. Now granted, there were 3 students that scored at 770, but when reporting the outliers, we just report the values. So 770 was the highest value, and you notice down here too, there were 320 is an outlier, and there were 3 students that scored that. When we go over here and talk about the outlier values, that's not how many people scored. It's the values themselves that were outliers. All right, gang, moving right along, come on over and we look at create a histogram. Well, the prompt for histogram is just, you would think it would be histogram spelled out, but it's not, just H-I-S-T. And we're doing math here, right? And up pops a histogram. And guys, this is about as bell-shaped and symmetric as one could possibly get from a sample of scores. So we created our histogram. The distribution shape is bell-shaped and symmetric. So guys, that's all I've got. We're now in a situation where we can get a little deeper into the data set and in terms of maybe looking at, for example, math scores across gender. And that's what will be on the agenda next. So guys, that's all for this video. Hey guys, Dr. Darbro. I realized that the last video I posted on Introduction to R with Descriptive Statistics, I got a little windy, meaning that I went overboard. We try to keep these videos at about 10 to 12 minutes, and I think the last one was about 20. So, sorry, didn't realize that was going on. So, guys, I've shut things down. I've still got the worksheet handy, but I shut R down because I wanted to go through once again, bringing, opening the data set from the desktop. So nothing has changed in terms of that. The only thing I did is I got rid of the XLS format because all I need is the text, but it's saved it as SAT. So over here, what would I need to do first? If you're comfortable with the way that your working directory is written out, then go for it. But I'm not. I've done this quite a bit. I like to see it. So I get my working directory. Notice that it's reset everything. So I need to set it in terms of users, ddarbro, and set as desktop. Guys, capitalization is important. Desktop has to be capitalized, but that's the beauty of getting your working directory, is you can see the other things that are included, what needs to be capitalized and what doesn't. All right. Feel pretty confident. I'm going to call it my data again, and I'm going to read .csv. I call this sat.csv. Now I'm getting a little bit more confident. Well, I mean, I'm confident to begin with on this, but maybe you've got a little bit more confidence now in that it's working. We don't really need to see the data. We just need to go ahead and get it ready to work with, okay? So remember, guys, we're not going to be able to do a histogram, a box plot. We're not going to be able to find any numerical summaries until we attach our data. Now, if you're excited about that and you just want to see the fruits of your labor, then type my data, and you can see that we have our data. And since we've attached it, we're ready to work with it. All right, gang. Again, in an attempt to keep this video shorter to make up for the extremely long one I posted last, let's go over to the worksheet and see just exactly what we're supposed to do. So what I want to do now is I want to look at SAT math scores, but I want to look at these across gender. So I want to examine important characteristics of the SAT math scores, but I want to divide those across gender. In a nutshell, I want to look at the mean, the median, standard deviation across males and females. Now, the way that we do that is like this. I'm going to call this summary, and I'm going to use what's called the t-apply function. Now, the t-apply function, the first thing I'll put is a quantitative variable. Then I'll put the categorical variable, and then I'll put the numerical measurement, the numerical summary measure that I want to find. Now, for example, what if I just wanted to find the mean? Well, it'd be kind of goofy to call it summary. I'd probably just call this mean, and I would type mean here. Now, if I type mean, it's going to give me the mean across gender, each for females and each for males. I could do the same thing for standard deviation. T-apply, math, gender, and tell T-apply what we wanted to find, so to speak. Doesn't give me anything. That's good. I got to tell it standard deviation. So right off the bat, I could come over here to my worksheet and fill in that the mean for male was 564.59. The mean for females was 521.94. The standard deviation for males was 82.31. The standard deviation for females was 81.27. Right? Yeah. So in terms of variation, very little difference in variation around the mean. But you can see that the mean for males is about 43 points higher. Now we'll want to do the same thing for the median and the quartiles and IQR and range. But as we saw before, we can find more in just one command called summary. It's kind of weird. Nothing happened. That's good. So guys, what this now allows us to do is allows us to take the female, the 5-number summary, the median, mean, and so on and so forth, and then compare with males. So guys, the median looks like it's 520.0. No, it's for males is 570. And for females, it's 520. So males appear to be scoring a little bit higher. Trust me, I don't know what that means because some of my best students in mathematics have been females. So what do we got for third quartile? 580. Now, gang, IQR. For males, probably the easiest thing to do for males is just take 620, subtract 510. You could probably do that in your head. If not, don't sweat it. Use R. And what do we have? 110 again. Wow, that's interesting. It's really interesting. Okay, so the spread around the median, remember, standard deviation is a spread around the mean. So standard deviation and mean are kind of married. Okay, median and IQR are kind of married because IQR is the spread around the median. So the spreads around the median and the spreads around the mean, there's not much difference in the variation or the variability in scores. Math SAT scores across gender. Gang, it looks like for males the max would be, I'll tell you what, I'm not even going to test my mental arithmetic, although I can do this in my head. I want to show you that there's nothing wrong with that. There's nothing wrong with coming here and taking the max of 770 and letting R subtract 290 from it to get 480 for the range of males. And if you need to do that for females, again, nothing wrong with it. We have 770 minus 310, which gives us 460. So all of the measures of spread, all the measures of variability, the standard deviation, the IQR, and the range give us approximately the same values. Very comparable. And both measures of center, the mean and the median, give the male having a little higher score. All right, gang. Next thing I want to show you is how to prepare a side-by-side box plot to see if there are outliers. It turns out this is really easy too. What we'll do is we do math tilde over gender. Now, if you're having a hard time finding tilde, go to the keyboard and find the 1 key. Not if you're on PC, the numeric pad over here to the right. I'm talking about the 1 above the Q. Go to the 1 above the Q, look to the left. As a second function key, as a shift, you'll see the squiggly, what we call tilde. Guys, once you get that, hit enter. And the box plots demonstrate exactly what we got numerically. There's not much difference in variability. The difference of IQR are the same. The difference in variability, the same, mostly speaking. But the measures of center, and of course the only measures of center that we can compare with box plots is that of the median. So guys, what would I do next if I were you guys? Well, I would do what I asked you to do a while ago. I would go to the back 3 or 4 pages in my notebook. And I asked you earlier when you're keeping your video journal to keep kind of a running notes of the things that we learn in R. So what kind of things I think you should add to your bag of tricks? Well, definitely how to set working directory, how to read a file, how to attach it. I would do the tapply function. I would remember the summary function, and definitely would want to do the box plot. Now, you may be interested, I don't know how this works. It's not a pretty picture. It's not really pretty because... And we don't get anything there. Histograms, we don't want to separate histograms. So just box plots. All right, gang, that's it. I promised you I'd try to keep this one shorter, so hopefully I have. Have a good one.